Góðan daginn allir, velkomin á þennan föstudags fyrirlestur. Við erum með hann Bjorn Sundling með okkur sem ætlar að fara yfir Bicep, infrastructure as a code, og við bara þökkum honum fyrir. So thank you Bjorn for giving us your time and
My pleasure.
showing us your knowledge on Bicep. So I'll just give you the mic and you can start.
Yes. Thank you very much. Hello, everyone. It's really, really fun to be here. Really fun to do this. I am terribly nervous, like I said to Gisli just now, but we'll hope this will work out just fine. I'm going to try to, well, let's do this maybe. And we can start my presentation like this. And we'll see how this works out. Yeah, so my name is Bjorn. I do my daily work at Advania Sweden as a consultant, where I do mostly pipelines and PowerShell, but my team works a lot with infrastructure as code, Azure, automation in all types and kinds, and so on. My own focus is mostly, like I said, on pipelines and sort of getting what the coders write out to what the architects design. That's what I enjoy doing. I have some titles and certificates and stuff. I am not an MVP, but I have some of those Microsoft shields. I don't really care. You can find me on Twitter if you have any questions after this or so on. You can follow me on Twitter right now. Currently, Twitter is sort of, I don't know, the big Twitter exodus is going on. So I'm also on Mastodon, but haven't included the link here. Also have a webpage, bjompen.com, Bjompen being my general nickname everywhere, where I write, rant, and post blog posts every now and then, mostly about Azure DevOps, but about GitHub and pipelines, and every now and then about other stuff as well. When I'm not tech nerding or consulting, as you can see in the picture, I ride my motorcycle and yeah, like so many others, have a family and pets and so on, and other hobbies. Doesn't really matter right now. Today we are going to talk about this. We are going to look at some Bicep basics. Bicep as the infrastructure as code language. We're going to look at how to get started with it, sort of how to get over the hurdle. We're not going to do a deep dive or advanced functionality. We're actually going to brush through Bicep basics quite fast. And that is, well, partly because it's an introductory presentation, but also because, well, I am not a Bicep professional. I write Bicep code, but there are others who can do advanced Bicep better than me. What we will focus more on is sort of how to get from Bicep to infrastructure as code once you have done this. So we will start by looking at some beginner's pipeline, some deployment methods, how we can get some feedback from our deployments, or from how we can improve this infrastructure as code thinking. Once we have started looking at this, we will look at some medium advanced and some super advanced ways of sharing code, or, well, everything is easy if you know it, but some different ways of sharing code, of sharing this infrastructure with our users. So before we kick off and jump into demo mode, what is Bicep? Well, simply put, it's kind of the new ARM language, ARM being the underlying language of more or less everything you do in Azure. It's Azure Resource Manager. If you are clicking in the GUI, creating a new resource or whatever, it's the ARM APIs used underneath the GUI. It is a domain-specific language, so it's created specifically for deploying Azure resources. So why, when there is a ARM language already, why did we even bother creating, or why did someone bother creating Bicep? Well, ARM works. ARM is JSON-based template language, but it's quirky. JSON isn't really meant for human readability. It's really, really big, really. So you could write your templates in it, but it wasn't that easy to read, write, or restructure. So we invented. Someone created Bicep with more focus on human readability, on how we would like to have written. It's someone said it's what ARM should have been from the beginning. There are some really nifty features built into this. So, for example, if we are using the built-in Bicep plugins for Visual Studio Code, where we write our code, we get auto completion that we will look at in a short while, really fancy. And all of this, or lots of these nice Bicep features that we will see, comes from the fact that we talk directly to the ARM API, kind of. We get the version of APIs compiled into Bicep. So whenever there's a new release of Bicep, we get sort of everything that exists in Azure supported in there. And what I mean when we talk directly to the ARM API is that ARM API documentation, or the actual ARM API itself, is what is part of what creates Bicep. That means that unlike, for example, Pulumi or Terraform or other languages where you have to build modules, you have to build new functionality. So if there is a new feature introduced in Azure, they have to build modules to support this, whereas Bicep already has this. On the other hand, Bicep only supports Azure as of right now. So deploying your Bicep code is, well, it can be done in a number of ways. We're going to look a little bit at the AZ CLI and a bit more at Azure PowerShell, simply because I'm a PowerShell nerd by heart. Like I said, I've been doing PowerShell for many years and feel more comfortable doing it. If you want to do AZ CLI, that works just as fine. Both of them are first-class citizens of the Bicep language. We will also see something. I will sort of just mention it right now. When we do deployments, we can, of course, do deployments on all kinds of scopes in Azure. So we can do subscription deployments, we can do resource group deployments, management group deployments, and so on and so forth. In this presentation, we will more or less only look at resource group deployments, but you can actually run these kind of deployments. You can run these pipelines for any kind of resource, no matter how big or where it goes in your Azure structure. So, brief, short introduction. Let's go look at some code. Wait a second. This was a problem. Let's do like this. So, like I said, when we start using this, if we use correct plugins, in my case, I have already installed the Bicep plugin for my VS Code. What we need to do is just switch the language mode and say, let's run Bicep. You can do this by either click F1, or you can click the language mode down here and select Bicep in your window. Bicep is structured quite simply for humanity. It contains a keyword. Everything you do starts with a keyword and then a reference name, and then whatever parameters this keyword requires. So we're going to start really simple by creating a resource. Today we're going to look at deploying a storage account. So we're going to start by creating a resource. Logically enough, the keyword for creating a resource is Bicep is resource. You can already see the auto completion. This is VS Code standard features, but the Bicep one works really well. So it's really quick and tells us right away what we need to do. Once you have used your keyword, you decide what to name your resource. In this case, we're going to call it whatever. We can call it my storage. There we go. My storage, like this. We're going to create a storage account. This is just the internal working name within Bicep. It doesn't matter what you name it here, because it's not what the resource will be called inside your Azure structure. We will look at how we reference this and why we do this in a short while. Once we have done this, the resource keyword requires you to give it a parameter saying which resource type it is we're going to deploy. And this is where the Bicep linter, the Bicep VS Code plugin actually starts to shine. So I just have to, press space and this shows up. And it's auto completion, it's auto type. So we're going to create a storage account. We just we just write storage account like this, and it will show us everything that matches our query. So, we click enter, and it tells us we need to define which API version we want to run as well. And like I said, this is compiled into the latest Bicep. So in fact, I wrote my demo code that I have in the background here a couple of days ago. I updated my Bicep yesterday, and apparently they have updated my Bicep API version, or my storage account API versions since. So we automatically get support for everything for the latest and greatest as soon as we update our Bicep version. So the format of this is your resource at, and then which API version we want to create. So we're just going to go select the latest. After this, click space and the auto completion shows up again and says equals or existing. We're going to create a new one, so we're going to pick equals. And here is another really, really nifty feature for getting started using Bicep. Once you have typed equals, you get a auto completion for required properties. Now, just for show, if this doesn't show up, if the auto completion doesn't work as expected, you can always click Control and space, and it will autocomplete wherever you are, or tell you what you can do right now wherever you are. If you choose required properties here, it will tell us automatically these are the properties that a storage account needs to be given. We cannot create a storage account without these properties. So we're going to just give it values for everything in here. So for example, we can say a name, my storage account like this. A location, we say West Europe. We can give it a name of the SKU. And here like I said, most of this is compiled into Bicep. So it already knows what kind of SKUs exists for a storage account. Let's just go with standard LRS like this. Now, I'm not going to bother actually filling in the rest because in order to sort of move on, we can already see that we have a yellow twiggly in here, telling us that we shouldn't use hard-coded string for stuff like locations. Why? Because there are better ways of doing this in Bicep. We can use the quick fix here, or we can just move this, like it says in the text, move this up to a parameter value. Using the quick fix. Come on, should. There we go. Now we are seeing the next level of the Bicep language. So again, we are using a keyword here, a param keyword, parameters. We're giving it a name. It is of type string. So in this case, instead of saying we need what kind of resource type we're creating, we need to say that this parameter is of type string. It is a string input. There are also a number of other types of inputs that we can use, and we have given it a default value of West Europe. This also works. But again, in order to move on, we're actually going to improve this as well and look at a third functionality in Bicep. So instead of hard coding this, we can tell Bicep that we want to deploy this storage account in the same place that the resource group that we are deploying it to exists. And this is a function. Bicep contains a number of functions. We will look at some of them very, very soon, but we're going to start with this resource group location. So instead of giving it a hard-coded value of West Europe, we can say, well, maybe I want to create some resources in Sweden Central and some in West Europe. We can instead then say, use the resource group function. Now you can see that this is a function because it contains parameters. Use the resource group function to fetch the resource group we're currently working in and publish it to the location of this resource group. So now we don't have to tell it hard-coded where we want to deploy this, but instead, after we have created a resource group, we can just say, well, use this. Apart from this, we're going to look on some other features. Like I said, this name, the resource name in this case, is just an internal name. So, oh, wait, scroll too fast in my cheat code. Here we go. First of all, we're going to give it a type. Going to make a kind, a storage v2 kind. Now, a storage account isn't of much use unless we actually use it to store stuff in. So we're going to create a blob service and a container to actually store our whatever it is we want to publish as well in here. So like I said, this resource, it's a resource named my storage, and the my storage name is only an internal reference name. So when we create a blob service, that is the service that contains our storage blobs inside our storage account, we can say that this blob service should be tied to this storage without having to build nested deploys and stuff by ourselves. So we are going to create another resource down here. Resource, same keyword again. And we're going to call it my blob service. Like I said, this is the service that contains the actual storage blobs that we're going to look at. In this case, the type that we're going to create is a blob service. Auto-completion works just fancy like this, and we're going to give it an API version. We're going to say it's a new one, and the required properties in this case is just a name. So we're going to give it a name. Not ask me why right now. A name like this. So the reason it's currently erroring out is because it needs to be related. A blob service needs to be related to something. And we can use the keyword here, parent. And again, like I showed you up here, if we don't know what to do, we can always click Control Space, and it will tell us, okay, these are what values we can fill in our resource right now. So we're going to tell this that the parent, the owner of this blob service, is the my storage. And we use the internal name, my storage, to say that, okay, in the background, Bicep will now figure out that, okay, we will need to create this one first, and we will need to get all the properties back in order to connect these two resources to each other. So we have a bit of functionality that we have looked at. We have parameters. As of this description, we have something called decorators that we can connect to certain keywords. So this simply helps us know what goes on in Bicep. It helps us with some error messages or other stuff that we can sort of use. We can use decorators for all kinds of different stuff. We have parameters using the keyword parameter, internal name, and a property. We have resources, internal name, and the parameters needed to create a resource. Now, of course, I am a good proper TV chef, and I have created all this ahead of time because it would take too much time to go through all of this. Like I said, I updated my Bicep, so you might notice that we have actually bumped the version numbers here. And we have added some more functionality. So we still have the resource group function here saying that we want to deploy this code into the same location that our resource group is located in. We have also added a new keyword here called var. This is a variable, so it's a static value inside Bicep that we can use just as a parameter or whatever, but we build it during runtime. It's simply internal to this Bicep template. We are using some more functions. So a blob, the storage blob, the storage container itself, These has to be globally uniquely named in all the world. We can't create a blob named something else, and this is really hard to do by head. It's just you could always smash your keyboard and hope that it's globally unique, but it's no guarantee. So we use a function. Again, you can see by parameters, creating a unique string, and we create this unique string based on the input parameter name, the resource group name, and the subscription ID. This will create a unique string of, I don't remember how many characters right now, but a unique string that we can use to deploy. And the chances of this not existing somewhere in the world is far greater. So we also can't name storage account anything but lower character letters. So we're using yet another function called toLower to make sure that even if we give it parameter with capital letters, it will only use lower cases in the storage account name. We're using string interpolation here. Instead of just saying that, okay, this is the name that we're going to name everything, we can say that, okay, the storage account should use our parameter name and then append SA to the end. We're using a function down here called take that makes sure that, okay, if the storage account name, a blob can't have a name longer than 25 characters. If my blob name, if this unique string would end up being too long, then we will simply say, okay, just take the first 25 letters of this and name my blob like that instead. So we have a couple of different functions, a couple of different keywords that we use, and so on and so forth. This to create a storage account, a blob service, and a blob inside of it. Now, like I said, this is closely related to the ARM language, and in fact, gonna see, no, wait, long window, there we go. In fact, it's so closely related that this Bicep file will actually compile into a ARM template. So while this may look a bit, shall we say, a bit hard to read, it's still sort of understandable. Everything is easy once you know it, but it's still kind of understandable what goes on in this file. When we run Bicep, we could run the command AZ. Did I just type in the wrong window? I typed in the wrong window. I just overwrote my entire demo code in the background. Thank you. AZ, and we can use AZ, and we can use Bicep like this to build a Bicep. We're going to look at a couple of different ways of doing this through the presentation. We can use the AZ CLI, which has integration to Bicep, and do a AZ Bicep, build dash file. I'm hoping this works now. And we say build this file, build the storage account.bicep. Come on. See, again, I updated my Bicep and also the Azure CLI yesterday, so I haven't verified. So what happens now is this Bicep file that we have in our VS Code, it has compiled into a JSON file. So this JSON file is the same code, but in ARM template format. We can still see that we use we only have lowercase and so on. It actually compiles into normal ARM code. And we could deploy this ARM code right into our Azure. But since, I don't know, a while ago, we also have made Bicep a first-class citizen of all our commandlets and commands. So once we have created a Bicep file that we are happy with, that works the way it should, we could use, let's see, I hope I connected, I should have connected, the commandlet new AZ resource group deployment. This is the PowerShell commandlet that we need, that we use to deploy a Bicep or a JSON or a ARM template or whatever. So we're going to create our first deployment here. It's going to have a name. command. Please load the commandlet for me. Okay, I forgot to import the AZ commandlet. So yeah, it's going to have a name. We're going to give it a name called my deployment. This is only the name of the deployment. Again, some things doesn't really matter. You can name it whatever you want to, but they need to be there in order for the commandlet to work. Sorry, I actually forgot one thing. I'm going to have to go back and look at my demo code because there we go. Because, of course, there is let's do it like this. There we go. Of course, there is a couple of pre-requirements that we need to do. So we need to define where do we want to deploy. Again, I said we can state one location and we can use that throughout everything. We need to also tell it which resource group we're going to work with. Right now, we're going to work with a resource group called Bicep for Beginners. And I had forgotten to set this. I should have done this before. I have also logged in to my Azure account. So I already have a service or a connection to Azure. So what we need to do when we deploy our Bicep code, we use the commandlet new AZ resource group deployment like this. We need to give it a name, my deployment in my case. We need to tell it which resource group, because we are using the new AZ resource group deployment commandlet, we need to tell it which resource group we are going to deploy to. In our case, we just set this Bicep for Beginners. And like I said in the presentation before, you could do this on other scopes as well, but resource group made sense when I wrote this demo, so resource group it is right now. We are going to tell it that this is the template file we want to use. We just created the Bicep file, and we're just going to deploy this right from the start, the way it looked. We had a couple of parameters here. One of them, the name, does not have a default value. That means we need to set this parameter before we can deploy this. So we're going to give it a template parameter object. Now this is specific for how you do template parameters in the PowerShell commandlets. We give it a template parameter object and a hash table defined by whatever these are called. And we say name should be my first blob. Now I have also added a nifty little switch called what if. The reason for this is that I have deployed this and redeployed this so many times before. So the what if will simply, instead of deploying it, show us what would happen. If we run this down here, hopefully we should get some feedback. Come on, Azure, please go on. While we wait for this, we can say, like I said, we also have the AZ CLI. Both of them are very much first-class citizen. So if you prefer this, you could also do AZ deployment group create, which is the exact same command, but AZ CLI. Just like with Azure PowerShell, we have to give it a resource group, a template file, and we have to give it some parameters. Now, in this case, I have actually given it the parameters from a parameter file. We will look a bit out at how we create this in a very short while. But you can also use the AZ deployment group create if you prefer that. That said, we have some outputs down here. I added it disappeared, but okay. I added the what if switch to this, which means instead of actually doing the deployment, it can tell us that when we do this deployment, this is what will happen. Okay, we will change this and we will set some values to this resource. We will also look at this a bit more in a short while. Removing the what if, well, simply does the deployment. Now, the ARM language, or ARM as a API, is aware of what's going on behind the scenes of what everything is. So it will actually just do the changes required, since I already have created this in order to be able to demo it. It will only do the changes required right now, which apparently was 2 resources we needed to change. Okay, so let's go back to this one. We have created our first resource and we have deployed it from console. That's all fine and dandy, but it's not really infrastructure as code. And this is normally where my work starts and where my interest starts. We're going to make this a bit more automatic without getting too advanced and making it too hard. So we're going to look at how we can use parameter files instead of static parameters. Why? Because then we can separate a bit of ownership. We're going to set up our first repos, our first pipelines. We're going to look at a couple of ways deploying this, and we're going to set up some feedback. Now, in order to do this, like I said, the first thing we're going to look at is the parameter files. You could absolutely, let's go back and look at this one. There we go. You could absolutely do it like this and say, these are the parameters we want. But that would require everyone who wants to deploy something to change your pipeline. Instead of changing your actual code, you will have to go into the pipeline deploying this and say, okay, now I want the parameter to be this instead, or that instead, and so on and so forth. Not really scalable, not really doable in a larger than very small scale. So before we actually start to push this into a pipeline, we are going to create a Bicep parameter file. Now, just like with everything else, I want to show you a couple of different ways of running Bicep, a couple of different ways of deploying stuff. So in this case, we're going to use the Bicep CLI itself. Before we use the AZ Bicep command. In this case, we're just going to run bicep.exe like this. We can do like this to just verify which version. I updated it yesterday, so it should be the very latest. I hope so. And we can run bicep -help like this to see what we can do in Bicep. We could, there's a number of things we can do with the Bicep CLI, of course, but we are going to look at this one. Bicep space generate params, and then our file that we want to do it for. Now, the file that we want to generate parameters for is, of course, our storage account. So we're going to do bicep space generate -params. Let's see if I spelled it okay. Params, yep. And we're going to give it our file. Storage account.bicep. So the CLI will now, we can actually deploy or delete this just for the good matter of it. The CLI will now look through our Bicep code, look what parameters are required. And that is, in this case, only the name, and it will create a parameter file of this. So we also have the parameter location, but since this have a default value, it will not be included by default. We could, but it's not necessary. So running this, hopefully, demo gods, thank you. Running this gives us a storage account. Instead of Bicep, it's parameters.json. Looking at it, well, we have a schema, we have a version, we have a parameters block with one parameter called name and no value. We need to give it a value to run. So one question or one thing curious-minded people wonder about is how come this is JSON? Well, I thought we said no JSON. Well, we said no JSON. There is a Bicep parameter format coming sometime. We don't know when. But as of now, it's actually the ARM template format. So we need to use JSON format. Fortunately, it's kind of easy. There are very few functions or stuff like this. It's just a parameters block and the name and the value. Now, depending on which type. In this case, it's a string, so we can just give it a name value, my storage blob like this, or storage account, my storage, let's just do like this, and it's good enough. If it's an array, it might look different. If it's an int, it looks different, and so on. But it's actually, it's at least doable. It's somewhat simple, and it's what we have to live with for now. For the sake of it, let's just do this, because I can't remember what I named it before. No, I actually did name it my storage. Good. Okay, so we have generated a parameter file. It's time to push this up to our repository and start looking in here instead. Again, like a good TV chef, of course, I have already done this and pushed up my code up here. So we have my storage account.bicep. We have our parameters .json. Although the date and version is quite different, it's the exact same content as the repo we are currently working in VS Code. So we're going to start doing this automatically. We currently just have it in a repo. We need to set up a pipeline. Now, just like with everything else in IT, there's a million different ways of solving the same issue, and we're going to look at a couple of them. Creating a pipeline in Azure DevOps can be done either by clicking Setup Build here, or you can go into Azure DevOps Pipelines and click New Pipeline. Once this is done, you have to select your repo. We only have one in this case, and we can select a starter pipeline or an existing YAML file. A starter pipeline would just give us a very basic way of running stuff. Let's just do this for now. So it will give us a starter pipeline, gives us a very basic way of running stuff. And what we need to do, we can actually just skip this instead. Sorry. Let's go back here. So once we have done this, we need to set up a couple of, once we've created our starter pipeline, we need to set up a couple of prereqs in order to actually deploy code. The first one being service connection. Once you start to deploy stuff using pipelines, we need to figure out or set up some access controls as well. So we're going to start by looking at a service connection. A service connection is simply a way of Azure DevOps. I may mention the same thing exists in GitHub or whatever you use to deploy stuff. I just prefer to work in Azure DevOps. A service connection is basically the way our pipeline can talk to Azure. I have, like with everything, already created one. It creates a application. So if we go into our Azure AD, you can actually see we can do this instead, like this. We can see the service connection ID. It's a identity inside Azure that it will use to speak to your Azure environment. Now, of course, this also requires you to set up some access to this service connection. In my case, we have a service connection. It's just a normal application in Azure. In my case, I have granted this application ownership of my resource group that I want to deploy in. You could, of course, set it up as contributor or whatever it is you need to do. But the important thing to remember is that this is an identity that we need to give some kind of access to our resources. This service connection can then be used inside a pipeline to talk to Azure and perform the deploy. So instead of going into VS Code and typing, I want to do new Azure Resource Group deployment, the very first step of moving from manual work to a automated pipeline would be to simply set up a pipeline, and we say run this on any kind of pool image. This is a Azure hosted image, and we say use Azure PowerShell. Same commands that we just used in VS Code, the AZ commandlets. Use this Azure subscription. Like I showed you, we have this subscription, this service connection. It connects to, it's named Bicep for Beginners, and it connects up to my Azure environment. Just like when we deploy deployed using our own commandlets. We need to tell it which resource group, because again, we're using resource group deployment because I thought it makes sense. Whether you want to put it like this, or you can use variables inside Azure DevOps or whatever, that's totally up to you. But the very first sort of infrastructure as code step, going from creating a bicep to running infrastructure as code, would be take the exact same code, take the exact same commandlet, create a parameter file, because then you wouldn't have to rebuild your pipeline each and every time. And the only thing we actually change is this. So the only difference between the command we run in VS Code that used a template parameter object, we now use a template parameter file with the template parameter file that we just created and uploaded to Azure. Also here, I have added the what if. Again, I have deployed this pipeline so many times by now that, okay, thank you, that I kind of was afraid that it would break. So I just added the what if to everything and made sure that nothing breaks. The only difference is that the output looks a wee bit different, but it still works. Running this pipeline, well, it would use this service connection. In the very background, Azure would Azure DevOps would actually check this out and do a connect AZ account in pretty much the same way I just did. And it would, we can actually look at the pre-run. It would connect to Azure, it would run the Bicep code, and it would do a deploy. And it would output something like this. So apart from the colors, which just disappears for some reason, we get the exact same result in our pipeline here. It creates a Azure connection, it deploys our resource, assuming that our service connection account has the correct access to our Azure environment. Okay, now there are issues with this. I'm just going to blast through it because it's one of my favorite things to talk about. Many people, companies, organizations that I work with, they do not want Azure hosted. So like I said, this service connection or this pool, it runs on a Azure hosted VM. That is, Microsoft manages updates, make sure that software is there. Really good, because all the software I need is already installed. But it's also on a public IP, so it would require someone from a random public IP on a machine that I don't own to have loads of access to our Azure environment. Now, I have more than a couple of customers that don't like this. So you could also set this up to deploy on internal machines. In my case, I always promote using VM scale sets. You could also do it on your own hosted VMs, and it works a wee bit different. When you set up your VM scale set, you also need to use a service connection, but that service connection is only used to scale it up and down. The scale set itself can have a managed identity. And then instead of giving your service connection account access to your environment, you give the managed identity access to it. Wait, wrong button. This also means that you need to maintain the software that you need. In this case, I set it up to deploy on our scale set pool, which simply is my internal machines. But I also need to manually install the AZ CLI because I don't have this, because I need to manage the machines in some way. That's a whole different presentation. But just as before, we could use whichever one. They will do the exact same thing. We just use AZ deployment group create. Same parameters that we looked at in VS Code. The only difference is that we use this format to tell it to run these parameters instead. Okay, all fine and dandy. We have created a resource. We have moved this resource to our repository, and we have set up our first pipelines to deploy this. Now, whenever someone, okay, I have no triggers, but if you activate a trigger to your pipelines, whenever someone creates a new storage account Bicep or a new parameters file or updates or changes, whatever, we will redeploy and update our resources in Azure. This is really good, but it's like we haven't really won that much from just keeping it here and running it on our computer. So we're going to look at a couple of nifty little features we can add to this. So, sorry. In most DevOps feature or Azure DevOps or GitHub or in most pipeline runners, you can set up pull request features. In Azure DevOps, we can go in here and we can go into our repositories. We can go into our Bicep for Beginners repository and we can set up a branch policy for our main branch. So we can use something here called build validation. Now, build validation simply means that it merges code. Whenever someone does a pull request, it merges the code that you want to do a pull request with. It runs this pipeline that we have defined here and does whatever that pipeline does. It also means that we lock down our main branch if this is active. So no one can do add code straight into our main branch. They have to go via a pull request to do this. So we're going to have a look at a pipeline called validate and get feedback that I set up to run kind of the same code. This is a bit more intricate, but that's mainly because of how Azure DevOps work. So instead of just having code added, and we don't really have any idea, we want the improvements of infrastructure as code. We want the feedback. We want the better of infrastructure as code. So we're going to change our commandlet and use the commandlet get AZ resource group deployment what if results. Now I hate this commandlet name. I also hate the reason it exists because the output of this, the input is the exact same as new AZ resource group deployment. The output is the exact same thing as we just saw when we added the what if switch to the new resource group deployment, but we cannot capture the output and do this from the new AZ resource group deployment commandlet. We need to use the what if result commandlet in order to capture the output of a what if deploy and post it back in some way. So what we're going to do is we're going to run this commandlet with the same parameters as before. Our name, our resource group, our template file, our template parameter file. We're going to capture this in a variable that we're then going to post into a file. And then we're going to use the Azure DevOps API to post this back as a comment of our pull request. You can do this in GitHub as well. It's dead much simpler in GitHub. I think it's like 2 lines of code. I have it somewhere in my archive as well. But again, I like Azure DevOps, so this is where I did it. So this is going to be run whenever a pull request is created to a repository. It's going to do a what if deployment of our template with the parameters, and it's going to post back this result of the what if deployment into our pull request. Again, TV chefing, I have 2 branches here. You have main and you have my new branch. So since I have locked down main now, whenever I want to change something, I need to create a branch of this. I need to I need to create a new branch of this repo, and I do my changes and I create a pull request to get them back to main. I have, of course, done so, and the pull request will then, using the API, post back the result. So, okay, if I merge this, ignore the fact that it's red, it's just because it's old. If I merge this, this is what happens. So it will have 2 modifies. It will modify this resource and it will say delete retention policy enabled false. It will also modify this resource and it will change whatever it is this means it will change. Now, just posting feedback is really good because now you as the repo owner can take action and see, okay, this is okay, I want to merge and so on. But we can also set up stuff like you are not allowed to merge until all comments are resolved. That means that whenever someone creates a new resource or changes a resource, it will create this, and you would have to go in, look at, is this okay to create? And if you do, you have to manually say, yes, this is okay, and then you resolve it, and then you merge it, and then we update. So you have got some feedback, some improvements of the basic infrastructure as code. Now, before we leave this, there is one more thing I want to show, and that is this one. When you set this up, we need to, every single project in Azure DevOps has a build service account. Now, by default, this build service account is what runs code on your build machines. So it's what is the account that will actually run the deploys or the post feedback. By default, this one does not have contribute to pull request rights. So in order to get the feedback, you need to give it the allow on contribute to pull requests, because that's what's needed to post the feedback account back into your account. So you could also start to look here at separating code. In my example, I have everything in one repository, but since you can actually set up triggers for your pipelines in different ways, you could, for example, have one repository with your storage account.bicep, and that repository has only you have access to. So you manage the storage account.bicep, and you define that this is how my basic storage account should look. You can also set it up to trigger on another repository with parameter files. And using some looping and some other magic, you could say, whenever someone posts a new parameter file that matches this format, rerun my storage account with that parameters and create a new storage account with that name. This way, you could kind of build a beginning infrastructure as code with some separation of duty. You would have the feedback because you can they have to do pull requests, so you can make sure that whenever they do something, your users do something or wants to add a new storage account, it actually looks the way you want it to. See if I have gone through all that I want to go through. I actually have gone through all that I wanted to go through. We're going to rush through a lot of things, so yeah. Let's go back to our demo. Slides is the name. There we go. Okay, so we have created our first Bicep. We have created a parameter file to this. We set our first pipelines up. We set up a feedback pipeline to make sure that we know what's going on. And by doing that, we also lock down the main branch. You could, like I said, separate the repositories and sort of start doing separation of duty like this. But the problem with this is that it doesn't really scale that well. Like it works if you are alone or if you are a couple of users. If you're a smaller organization, you might do this, and you might be okay with setting up a number of service connections and so on. But the problem is that as soon as you become more than a couple of people using this, well, you're going to work in different organizations in Azure DevOps, or you're going to use different scale sets to deploy your software. And there's going to be a whole lot of more Azure AD work or resources or access stuff to be, it doesn't scale that well, simply put. So we're going to look at a couple of ways of going a bit more advanced. Now, the first thing when I started writing this was looking at storing Bicep files in storage blobs. So you could actually just use your own Bicep. When you have done created a new Bicep file or published it or want to publish it, you publish it to a storage blob, and then you deploy from there. And everyone could read the storage blob, and it worked. But the only difference between how we deployed it right now would be instead of template file, we use the parameter template URI, and it's not that fun to look at from a demo perspective. So instead, we're going to look at something called template specs. Now, before we go into template specs, I learned last week, or if it was 2 weeks ago, about something called deployment stacks. This is still in private preview. Nothing is known. This just rumors sort of spreading, but I heard this in a community call and I sort of went nuts on the internet. I think I found one page mentioning it. It's something coming that groups deployments in some kind of logical life cycle. So it's said to be to make it easier to manage more than one resource. It's sounded very interesting, but like I said, everything is rumors, and it eases up the concept of managing the life cycle, the deleting of resources. So instead of sort of like a resource group concept, but for deployment. Again, this is just something I threw in here. It sounded cool and something at least I would want to keep my eyes open for in the future. But as of now, it's just rumors. We are going to look at some template specs instead, which is a way of sharing code, kind of reminding of how you create resources in Azure using the GUI. Now, we can do this in Bicep only, but it's really quirky because a template spec is a resource in Azure, and resource keyword allows us to create anything that Azure supports. The problem is that the resource of a template spec requires one parameter that is the code that we want to deploy, and that parameter needs to be in JSON. So we would need to compile our storage account Bicep to JSON and then include that in our template spec in some way, a template spec resource in some way. And it's not even that easy because it's also a lot of other messing about, such as formatting issues. We can't use certain characters in our JSON, such as commas. There are escape character issues and other stuff. The only really good part that I found when I researched this was that you can use Bicep functions inside your template spec research, but it's still really, really bad. So instead, we're going to do this using yet one more commandlet in our pipelines. So when using a couple of good parts about using template specs is that they support stuff like RBAC. So we're going to go into our GUI and look at how this looks when we have a template spec. I have here a template spec setup, template spec resource that is template spec resource created that contains one template. It contains a template that is our storage account. Now, say, go like this instead. This is a better way of looking at it. So I have one template spec imported. That is my storage account. And like I said, this reminds us of how you deploy stuff in normal Azure GUI. So we can go into a template spec and we can select it here. We see here that the template is here. We see which version we're on. And we can click deploy on it and run. And just like the parameters that we saw in our Bicep, we have our location with the default value filled in, and we have a name. So we can just deploy this just like you deploy any old resource in Bicep. I just realized that it's 1 o'clock. I hope everyone is staying, but if you need to go, that's absolutely okay. I don't have super much more to do to show you, but yeah, I'm just going to go on. Drop off if you want to, stay if you want to. That's just fun. Okay, so what is a template spec for real? Well, it's a Azure resource that we can use to deploy, using our Bicep templates, just like anything else. If we go into our VS Code, here we go. There we go. So we have our storage account of Bicep, just like before. If we go in here, whatever we need to use, we we will use the commandlet new AZ template spec. Now, even though we update or create or whatever we do, it's always the new AZ template spec. We need to give it a name, like we saw in the GUI. Template specs. Oh, sorry. No. Oh, I have a name there. Storage spec. We need to give it a name, whatever we want to call it. Template specs requires versions. So currently I have uploaded 3 versions. We can see this if we click versions in the GUI, 01, 02, and 0327. We need to give it a version. So they are fully, versioning is fully supported inside here, and we can choose which one we want to deploy. We need to give it a resource group name. That is the resource group where our template specs live. A location, because every deployment leads a location, and we can tell it that our storage account.bicep is the template file that we want people to be able to deploy. So we use our template or our bicep files just the same way, but we upload them as template specs instead. Doing this, we can bump the version number like this, F8 to run some code. Just going to do this to make sure it shows, and I'm going to give it this one as well, so we know everything is in place. And if we're on the new template spec, we use the same bicep still that we have used before, and we upload a new version of it, and hopefully, God's be willing, we should have a new version in our GUI in a couple of seconds. Thank you. Now, of course, we do not want to do this manually, so we have a pipeline that we can use to update a template spec. Oh, wait. There we go. Just like in the VS Code demo or VS Code, we need to give it a version. Now, like I said, since we support versioning full on, you probably shouldn't do manual versioning. You should do something like Semver or similar, but for demo purposes, we don't need to make it harder than it is. So I'm just going to use the build ID to make this one a unique deployment. Running this would, again, do the exact same thing as I just did. I created a 04 and, oh, sorry, there we go. Say, and we can run this. Again, we're using the Azure PowerShell task. We're using the Bicep for Beginners subscription, just like I showed you from the beginning. So this one will upload a new version of our template spec that people or our users can go in here and deploy. That is because this is an Azure resource. If they have access to it in the role assignments in Azure RBAC. So when we use template specs, we can define stuff like say, okay, this storage account should only be deployable by these people, the readers of this. If you're not a reader here, you can't, or higher, you cannot deploy this template spec because it won't show up. And the only one who can contribute to this, well, it's this pipeline. This is the service account I just run a pipeline with, this pipeline that we have up here. So I can update this using my repository, and my users who has read access to it can go in and deploy this. And they can deploy this template using, come on, oh, we have a new version here. They can deploy this template using the GUI, or they can use a pipeline, of course. Now, probably already know sort of the baseline of how to deploy stuff by now. We use the same commandlet, we just define something else. New AZ resource group deployment, but instead we use a template spec ID parameter instead of a template file. Like I said, and like we just looked at, storage specs supports template versions. And when you start doing automation with template specs, it's quite important to define these versions and say, I want to deploy version 0.1 or 0.2 or whatever version it is. So when a user wants to automate this, they should, before they write the code, go in and see which version is it that I want to deploy. The reason is that if I do an update, let's say I release a 0.5 of this template, and they rerun this with the latest just whatever, if I have changed, for example, my parameter set, then this would crash. They have a parameter file set up for this version. So it's important to start thinking about versioning here, both from the updating of your template specs, but also running them. Like run the same version, just like you do in Bicep when you select your API version when you create your Bicep file, like we saw in here. There's a reason why we need to choose this, because whenever I redeploy this, the same API version will behave the same way, as long as no one deletes API versions, and no one should delete API versions. So we need to have a version. Now, unfortunately, this is quite a quirky one. So we can use the command get az template spec. So we can use this commandlet to get a template spec version. It has a parameter called version where we can say, okay, get the template spec version 0.1, but the return value of this will still be an array of versions that only contains one version. So in order to do this, we need to run this command to deploy a specific version of a template spec. We need to get az template spec with this version, and we need to expand this property of this template spec. And we need to use this version ID when we deploy it. So there's a bit more code involved, but nothing impossible. So the reason I'm sort of mentioning or talking or looking at this is because I find template specs to be sort of a decent middle step between going all in on infrastructure as code and getting started on infrastructure as code. It's not, it may not be your first way of deploying stuff, but it allows your users to get used to deploying stuff in a pipeline. And it allows them to still, in certain extent, use the GUI to actually deploy stuff. So, because the next step in this is sort of going super advanced. Once you have started this, you are going to grow into this and want to go more and more advanced. But once you go super advanced, well, first of all, it's way outside of this scope, and it's a much bigger buy-in. So once you want to sort of go full in, you would probably want to go all in. Everything as code. You don't want to use the GUI anymore. You probably need to set up something like landing zones, enterprise landing zones, or enterprise scale architecture. And you might want to look into tools such as AZOps to manage all of this. But this is a huge step ahead. But there will be no more clicking. You will do everything automatically. Really good. But I mean, if you can do that, I highly recommend looking into it, because it's the magical world of everything working flawlessly. But it's kind of far from getting started by now. We're sort of getting away from the presentation and the goal of it. And also, we already are 10 minutes late, so we probably shouldn't really drag too much overtime and dig deep into this. So with that, I overdraw us 10 minutes and quick. Does anyone have any questions? Let's see if I can. Oh, sorry.
Yes. I was just wondering. Can you hear me? Sorry.
Yeah. Absolutely.
Okay. I was just wondering, are you using any testing like Pester for the Bicep files in your pipelines?
I actually have a extra demo, so I see that there are at least a couple of people here. If you are curious, I did set up just the other day. So about a month ago, the Ignite conference took place. And there was quite a lot of cool releases concerning DevOps-y, pipeline-y stuff. One of them that I really found nice is the DevOps security pipelines, Defender for DevOps. Thank you. Names hard. The Defender for DevOps stuff, which is a brand new fancy way of integrating simple security checks into your pipelines. It's supported for GitHub and for Azure DevOps as of now. And you set it up, well, this is all the code required for it. Right now, I'm running this short demo on Windows latest, but it should work on Ubuntu. I haven't verified it yet because the tasks run on .NET version 6. As far as I know, most of them run on .NET version 6. So Microsoft Security for DevOps is a nifty little tool that does all kinds of stuff, such as secret scanning, such as making sure you follow best practices, all kinds of really, really cool stuff. I haven't dug that deep since, again, it was released a couple of weeks ago, and there was they mentioned it in the opening session of Ignite, and then there was no more presentation of it. But one of the cool things that I discovered that it does is it scans Bicep templates for best practices. So, let's go into this instead. So I just hooked this up and said, run this on this is the same repository that I've been doing all my pipelines in. And it can say, okay, here's some bad practices or bad stuff that you have done in your template storage account.bicep. It's not perfect because, well, for example, this output here isn't really, I don't really know what this means. But if we go into the pipeline, we can say, okay, the tool, it uses a tool called PS Rule. Now, I have seen this one before. I haven't really dug into it because I haven't really had the time. But this one simply scans code for rules. Like we set up rules of how stuff should look. Again, the output isn't flawless, but, well, okay, apparently my storage account doesn't enforce encrypted storage connections, and that is something we should do. We could also go to the link here and say why. It tells us how. It tells us what kind of settings we need to check and how to do it, Bicep, and so on and so forth. So this is a really, really nice tool. It's actually on my next to-do list. I'm going to do a internal presentation of this because I find it really, really cool. So I'm going to dig a lot more into how this works. I'm definitely going to include this in my pipelines as of now and in the future because I want to make sure that this works. So Defender for DevOps. Oh yeah, it also gives you some. Let's see if I can find it here. There we go. If you have a security department that use Defender for, well, other stuff, it's added this little tab here. So they can use their normal portals. If you have some kind of knock or whatever, they can use their standard portals and their standard errors, and you can use your workbooks to take action on stuff and so on. And it scans and tells, okay, this is the status of this right now. It unfortunately doesn't show us the status of everything, but at least it's something that security departments can make do of. At least it's a starting point. Like I said, this is on my to-do and dig deeper in how this works, but it does give you some feedback on your templates, at least. Is that something you were looking for, or should we do? Was there?
Yeah, that's very interesting. That's actually not quite what I was asking for, but it still does kind of the same thing that I need it to do. So I was talking about like writing your own tests, but if we can do it like this, it's also quite nice.
I haven't written Bicep tests actually. I don't know if or how. I know if he's still in here, we have one of the greatest. Yep. We have one of the greatest Bicep persons I know in the meeting as well, Stefan, who might have some insight to this, but again, we're running over time and I want to put him on the spot. So yeah, I haven't done any pester testing of Bicep. I am not really sure. You could use the what if deploy and verify stuff using pester, but I'm not really sure what else I would test really.
Yeah.
Like
Okay.
the feedback I would want from a test would be what happens in Azure when I do this.
Yeah.
Maybe.
Yeah.
But it's an interesting topic, absolutely.
There was he said in the chat. I was actually wondering the same thing. He was talking about the dev stages or multiple stages. If you have multiple environments, can you, like for dev test UAT, how are you doing that?
I would look in. I don't have any demo of it, but I would use a combination in Azure DevOps. You have such features as environments that can help you do this. But above all, I would look into a branching strategy and different triggers and a couple of if statements in my YAML to see which branch are we running on. Like it's quite a large step from a one straight pipeline to a dev test stage pipeline, but it's mainly the important thing I would say is keep your Bicep files in one place. So one Bicep artifact to many parameters, for example, or kind of trying to see how to put it simply. Like I said, like dependency stages, if statements, and also using artifacts, pipeline artifacts in between to see sort of build whatever it is you need to deploy to different environments and so on. I have done this a number of times, but it's instead of one step and 20 lines of code, we're talking more a couple of 100 lines of YAML and multiple triggered pipelines in most cases.
Okay.
So I can absolutely come back and do a demo or a presentation on advanced pipelining, but as of now, I do not have it.
We are out of time, so I must say no more questions. So I think Ole can probably send you an email or something if he really wants to ask something more.
Absolutely, you have my contacts here, and like I said here, I can absolutely publish upload all the code into my GitHub repo if you want to, presentation and YAML and whatever. But other than that, thank you very much.
Yeah, thank you so much. Also, it was great to have you. Was very good to have the intro on the Bicep and also the advanced. It was very cool to see some of the features. Some of it I didn't know, so that was great.
Mm-hmm.
So,
yep.
Thank you very much.
Thanking you.
Until next time.
Yep.
Yeah.
See you.
Bye.
Bye.
Thank you. Bye.